national level workshop. Any kind of workshop, this is for the first time we are organizing. And credit goes to whatever the credit, I don't own any credit. Credit goes to the controller of examination, that will be in course, who happens to be the main, who played the pivotal role as the nodal officer of the Mission Life program, funded by the Pollution Control Board, Government of the West Bengal. And there are two dedicated soldiers, I would say soldiers, they are my soldiers, and two soldiers. One is Dr. Sajul Mondal, and another is our beloved Srija Madam from Srija. Oh, yeah. So, they are so shy, they don't want to get focused. But it has been made possible by these two dedicated faculty members under the able leadership of, I would say, in Bengali we call Pavel Manush. He is no one but Dr. Devadosh. So my humble regards to you all, sir. As you already know that we got a huge response. We got a response from 418 applications and 87 institutions. 418 applications from 87 institutions. Indeed, a matter of fact, right? And 22 states. So it is truly a national event. So a big round of applause to the organizers, not to me. Unfortunately, due to our limited resource, infrastructure, we could only accommodate 60 candidates. Again, but I believe that now our family is very small, but আমরা ছোটবেলা থেকেই তো যেমন ভাবে শিখি. Just yesterday I got to, most of you have also seen that video that went viral. Punch, a baby monkey and a monkey in Japan zoo has gone viral because his mother abandoned the baby. No one could help, but the zookeepers, they have made an artificial orangutan kind of thing, and that became a friend. And to be honest, do not feel abandoned yourselves, because we are a very small family, but our heart is big. In Himalaya, two terms are, because it is related to the mission life. We quite often we take into account the Himalaya. If we make a grave mistake, we call it as Himalayan London. And if we have a big heart, we call it Himalayan London. So I'm sure the controller Swajol sir and Srija they have Himalayan. So you owe a great sense of appreciation and sense of gratitude from all of us. Kindly forgive us for the inconveniences. I take the sole responsibility and unconditionally apologize for this. I wish a grand success of the continuation of program, and I look forward to meet you in the Eastern Metropolitan Bypass, where we will be encountering a different world. Thank you very much.
Now to proceed our session. To proceed our session, I'd like to introduce our guest. Dr. Bilan Basu. He is a seasoned geophysicist and managing director of Survey Systems Private Limited, that is based in Kolkata. Please, sir. And he has a vast experience in GIS and remote sensing from 1996, and today he is going to deliver us the session on drone technology, its principles, its operations and applications. So, now I will hand over the podium to him.
Very honor to everybody of you, to the honorable visitors, professors, lecturers, and students of various universities and colleges. I feel honored to address this August gathering. I will be straight away moving to the presentation, which will be mainly on drone as a technology and associated technology related with the drones. Those also will be touched upon to give you a glimpse of how the industry is moving. With that, I take the presentation and then we will have some live examples also. We will try to cover within roughly 50 minutes. To start with, what is UAV or drone? Which terminology is being used? The outputs, why we are using drone, what is the purpose, how does it compare with satellite images, applications of drone for natural resource management. The term UAV, it is unmanned aerial vehicle. The other term is drone, which stands for dynamic, remotely operated navigation equipment. However, India doesn't use UAV much. It is called as RPAS, remotely piloted aerial system. So we will also touch upon the DGCA as a drone. Now there are two types of drone which we encounter. One is the surveillance drone, which is used by homeland security, police, defense. And the other is the survey grade drone, which is used for natural resource management. Now what happens, what is the fundamental difference? I think you can understand. One is for surveillance during the crowd management systems. The other is for getting my mother earth, the resources from mother earth. So if you see the application areas which anybody of you are most aware, we will not digress much on it. You think of any applications in the industry that relates survey, that relates mapping, that relates agriculture, mining, crop monitoring, chemical applications, land management. So it is all pervading. Now, which way is the, since I am from industry, we will have a balance between the academics and the industry. A lot of researchers are going on, keeping in mind the national geospatial policy. What is the national geospatial policy all about? Most of you are aware. There are two stress areas. The one is the blue economics, which is related to coastal zone management and the area related, domain related to that. And the other is the three-dimensionality of the mother earth. If you think from the past 200 years, all our mapping initiatives have been done with respect to X, Y, Z has been done by a limited number of researchers, workers, and applications. Now, in a mass scale, India is drifting towards three-dimensional applications. Latitude, longitude, and altitude has now been given with almost any application we do. This is as per the National Geospatial Policy. Drone, fortunately, leads towards that. Application sensors leads towards that. Satellite image processing leads towards that. And the other is the digital India or the digital environment. We are hearing about 4G, 5G. So whatever we have done for the past 25 years in terms of GIS, image processing, analysis has to drift on the net. That is where the challenge comes. Because all of you are aware that satellite images takes a huge space. Drone image half square kilometer area is 2 GB of data. And I am saying you have to use it on a desktop, internet-based online system. This is what we require, the demand of the industry. So how do we get them married is the challenge of the industry. So the huge database has to comply with the framework of URL-based analysis, which we call as online analysis. The second is how we take those analyses which you are doing in various softwares in the online environment. That is one. Drone images, online systems. So here is where digital India's challenges comes. So three-dimensionality as well as, so these are the areas which we will more or less. Now a quick recapitulations of what we tend to do. When we speak of three-dimension, we are mainly speaking about digital elevation model, which is half the story. Digital elevation model, and the other term is the digital surface model. Fundamentally, had there been no trees, no buildings, no commercial anything which is not there, just bare art, that is called digital elevation model, which all of we are aware of. This is which is coming up in a huge way is the digital surface model, which will include all buildings, man-made or natural, which has a height. However, for all practical purposes of natural resource management, which deals with slope analysis, drainage system, watershed, etc., digital elevation model is what we want for contouring and other purposes. Now, where does digital surface model come into play? We will get into that. So, fundamentally, these are the two things which are important. It looks more or less like this. The upper part is what we have seen. The lower part is not much in use. However, very interestingly, whenever something is created from a process which generates 3D, which is the subject called photogrammetry, or most of you are aware of that, that the images are taken from two different angles of the same place. Just like the way our eyes see. Our eyes understands the depth perception because the left eye sees a two-dimensional image, our right eye sees a two-dimensional image. Those two-dimensional images are influxed, which is an inferior orientation happening in the brain to give us a perception of height. This is higher, this is lower. So we understand. So similarly, think that simulation when it happens on a commercial basis with satellites, with drones or anything, the same place is seen from two different angles to give us 3D. That subject is where aerial photogrammetry we have been discussing for 100 years almost. Now it has come very close to us, to you, to me. That is where drone comes to the picture. Now what happens in the drone? So since we are in a recapitulation mode, when you open a digital elevation model, you will see some values, 342, 326, that defines the elevation of the place from the mean sea level, which are in the last session from Professor Babu. So it gives me the elevation at that particular XY, 342. Calcutta and surroundings is 11 meters from the mean sea level. So we will get 11. Now that doesn't suffice because nowadays we are not speaking in terms of meters. We are speaking in terms of centimeters. So naturally our technology has to change. If it has to change, I have to get data like this, 0.81, 0.62. So if I move 1 meter, I should be able to get the fluctuation in the mother earth which the satellite or the drone sees. So to achieve this, we need some technology. Now, this is a very typical example of how QC is done by the engineers or something. This is a point on the road. If you see, it is simulating the natural arc. So both the DSM and the DEL are 641. It has to be same. The moment I shift the point on the top of a building, it then becomes 647 in the DSM. 641 remains the mother arc, bare arc. So basically, the difference is the height of the building, difference is the height of the tree, and this way, on a mass scale, we are trying to find out the differences of all the building heights, the tree canopy heights, and stuff like that. So this is what we need to achieve. Now, the problem of cameras and the problem of satellites, both has its own merits and demerits. When we are speaking of camera, we face problems like this because the camera frame will decide who is near to the camera, who is far to the camera, and give you an impression of what it sees. For example, here the plane is at the background, the statue of Buddha is in front. So naturally, in a single frame, you have two different scales, which as a geographer or a geoscientist, you know is not possible. So something has to be done. Something has to be done to bring it to the same scale. Now, how we look at the object is also important. When a drone flies, if you have seen closely, it tilts like this, changes direction. So when the drone is flying, the height from the ground is 100 meters, from the table it is 50 meters. Again, the same problem will come. So there is something called orthophoto, which means you have to see it from the top at 90 degrees. This is what happens. This is an orthophoto of the camels. The shadows are not the actual picture. The white are the camels. The camels are seen exactly from the top. So that is the shadow effect. Here the shadow effect eventually happens to be the object replica. So we face these problems. So when we are dealing with the drone for natural resource, these problems will come. However, there is solution for everything. That is called, so these are the terminologies which we need to know. What is the difference between an orthographic image and a true orthographic image? Now you see the building over here, it takes few seconds to understand the image. Here there is a tilt. Here it is more flat, taken from the top. That means the base of the building is having the correct coordinates. The top of the building has got tilted. This is half true. That means it is not called true ortho. So your drone should be able to give you true ortho. Otherwise, you cannot do any mapping work. So compared to simple drones which we see flying, to the drones which are required for natural resource management fundamentally differs in these areas which we should be careful about. In satellite images as of now, the highest resolution available for commercial purpose is 40 centimeters, whereas the drone will give you images of 4 centimeters. It can even go to 2 centimeters. So it is 10 times better compared to satellite images. The satellite image requires a minimum of nowadays 5 days to get the image. Whatever it passed today, you will get it 4 to 5 days later. This you will get within 1 or 2 days if you fly a drone. The working scale of satellite image is 1:2000, whereas the working scale of a drone is 1:500. So imagine the scale at which we are moving towards using drone. And finally, the satellite images, if not stereo, will give you mono information, whereas drone will give you a 3D information apart from the images. So this is very important. We get two things from a drone. One is the digital surface model, other is the mosaic. So what we get after flying the drone, processing it, you will get digital surface model, not digital elevation model. Digital elevation model is a secondary product. You will get this one. And the second thing which you will get is a mosaic of all the photographs that the drone collects in a seamless environment like this. So these are the two things the purpose of drone serves us. One is orthophoto, other is, so this is, I am in a 200 scale. You see, this is a clarity you should be able to get, which no satellite image as of date can be in this kind of analysis. So we are over here, there is a bird, there is a ground control station, there is a flight management software. So the UAV is called the bird in the terminology of US. Air traffic control is called ground control station, and flight management software is the man who is operating the drone, even if it is in an auto mode. So even if it is in an auto mode, there is something called flight management software. This together will be your drone. I just skip few of the things. This service ceiling is how high you can go. It is not called pixel size in drone, it is called GSD, ground sample distance, because the simple reason for a satellite, once it is flown, you cannot change the pixel size. For drone, you can manipulate the pixel size. You can make it 5 centimeters, you can make it 2 centimeters. Artificially, you can change within the software. That is why it is called ground sample distance. That means basically what area a pixel takes. This is the satellite image at that resolution. This is what you will get in the drone image. I will try to quickly show you a drone image. We will skip all these things. When you are flying drone, whoever the instructor is, but we'll be talking about pitch, roll, and yaw. These are specific terms to drone movement. Pitch means the drone looks like a square thing, but it has a front, it has a tail. When it moves forward or it moves backward, that motion is called pitch, just like a cricket pitch from two directions. When you are rolling, that means moving from one side to other, it is called roll. And yaw, imagine the Y letter, that means you are changing direction. So if you have to fly a drone, within the drone software or what you are manipulating, you will have to use these words. I am in a pitch mode, I am in a roll mode, or yaw mode. So these are the terms which you will be hearing. Now, LiDAR becomes another important area where the drone is fitted with a LiDAR. These are point cloud, which is no more images or it is no more photos. It is just picking up points. So it passes through the leaves, it passes through the transmission lines and falls on the earth. So it gives reading in a different perspective altogether. So these are very costly in the domain of photolite instead of RGB, but it gives us much more accurate data in terms of three-dimensional information. So all the rail track which you see, the roads, traffic generally have now moved towards from drones to LiDAR-based drones because we quickly get images and information in 3D. Now these are LiDAR images. So our automated, let us see this workflow which we will be doing in the practical. There will be a flight management software which comes in a tablet, like mobile, which you have. What is the function of the tablet? I am standing in a location and I want to survey this area. So you have to fix your area of survey. So what we do is, the red line which you see is drawn by your hand. Just draw the boundary.